This is a part 2 of earlier video, since this is some problem in the laptop, and again I'm going to back to the problem again. I want to discuss. One second. Right. Yes. So again, we are going to the problem number 1, and I'm repeating problem number 1. So the problem number is consisting of SKF 6210 deep groove ball bearing has an axial load Fa is equal to 4000 newtons and a radial load of for 5000 newtons. Applied an outer ring stationary, so therefore V is equal to 1. Since outer stationary, therefore inner will be rotating. Inner shaft will be rotating, and the basic static loading C0 will be 20,595 newtons, and dynamic load rating is 27,017 newtons. Estimate the life of the at a speed of 720. So here, the problems will be consisting. If the life of the bearing is given, we are supposed to select the bearing series, select the ball bearing, type of ball bearing, and if at all the life of the bearing is given, and you need to select the bearing number, or the bearing has to be selected from the manufacturer's catalog. When the manufacturer catalog is given, so here we need to calculate the life of the bearing. So here either way, problems will be consisting of two. One is, if the life of the bearing is given, you have to select the ball bearing, and if the ball bearing number and series manufacturer's catalog data is given, then we need to calculate the life of the bearing. That is also, we need to calculate the life of the bearing. So problems will be either way. So here, as per the problem, the given data is radial load is F4 is equal to 5000 newtons, and the Fa is equal to 4000 newtons. The speed of the shaft is 7200 rpm, and the basic static load rating is 20,595, and dynamic load rating is 27,070 newtons. So here, when you see the manufacturer's catalog, so here cropped and pasted part of the series. So this is 62 series, and 6210 series will be consisting of that is 10 means here 10 means 1 into 5, that is a 50. Similarly, 0.09 into 5 will becomes 45, and 11 into 5, that is 55. So here the SKF series 62 or 63 series, whatever it may be, the last two digits multiplied with the 5 will get the diameter of the shaft. So this you can easily select the type of ball bearing when the diameter of the ball bearing, when the diameter of the shaft is given. So you need to select the ball bearing for the series on particular series. So this is the point you have to remember when the problems are given with the shaft diameter. So when the shaft diameter is given, so you need to select the bearing based on the shaft diameter. So coming back to the problem, and in this particular problem, already two steps earlier what we have discussed that is already changed is completed. That is the first two steps, that is the calculation of radial load and the selection of ball bearing is already completed. So therefore we are straight away coming to step number 3 for determination of X value, V value and Y value for radial and thrust factors. Radial load factor and thrust load factors. So this is X and Y, that is the radial load and thrust factors from the manufacturer's catalog. So for which we need to calculate the ratio Fa by Fr, and sometimes it will become Fa by V into Fr. So there is a ratio that we have to represent, and the Fa by C0. These are the two important factors that I have to determine initially. So therefore, based on the given data, so Fa by C0 is equal to 0.1942. So I request all the students to keep the Xerox printed copy of this particular sheet, so that it will be easy for your understanding. and FA by V into FR is equal to 0.8. So the estimated value of, so here already earlier I have explained that we need to calculate the value of E. The value of E, this particular E we have to calculate, so that within that particular range we need to select the factors, that is radial load factors and axial load factors, X and Y values. So here based on that, so FA by C naught from the manufacturer's catalog, that is data from the data handbook 0.17 and 0.28 is given, for which E value is 0.34 and 38. So here we need to calculate FA by C naught for the value of 0.1942. So therefore the approximate value after interpolation you'll get 0.349. So this E value, so it has to be checked with the FA by V into FR should be greater than E. Under this particular condition, since 0.8 is greater than 0.349, therefore the interpolation for X and Y is necessary. So X value is already fixed, there is 0.56 from the data, only Y has to be calculated. So therefore, so for the value of 0.1942, so what is the value of Y we have to calculate. So therefore 0.1942 is equal to 1.275. So this is the Y value. So once we know the X and Y values, so we need to calculate the equivalent dynamic load on the bearing. So that is the equation is equal to X into V into FR plus Y into FA. So if we calculate 7,900, it will come. And the expected bearing life and the expression of life in millions of revolutions has to be calculated. So sometimes here the value we need to calculate with the load factor, that is service factor. So you can multiply here if the service factor is given in the problem. So in this particular problem the service factor is not given, so therefore you can eliminate that particular step. And therefore directly we will be coming to C is equal to PE is the dynamic, that is the equivalent load, into L10, that is the reliability of 90%, that is given in the problem, and generally we consider 90% of reliability. So therefore the life of the bearing we have to calculate. So life of the bearing already given, that is going to be life of the bearing in revolutions they have given, that is we have to convert into in terms of revolutions. So here the problem will be consisting of this life of a speed, that is estimate the life for 720 RPM. So at 720 RPM, so we need to calculate the life of the bearing. So that is to convert into number of revolutions. So when you have the value of dynamic load capacity, equivalent load, so the life of the bearing in terms of revolutions is 40.2 millions of revolutions. So this millions of revolutions converted to number of hours based on the rated RPM. So rated RPM is 720 RPM. Therefore, number of working hours is going to be 931 hours. So here in this particular problem, so this particular aspect, that is selection of X and Y values is very important. So X and Y values means first FA by SC naught has to be calculated, from which E you have to calculate. To that particular E level, again you need to calculate the value of Y value. So this calculation part is very important for calculation of equivalent load carrying capacity of the bearing. Okay, so here once if you calculate this particular one, so life of the bearing will be calculated. So here in this particular problem, the bearing number is given, so therefore you need to calculate the life of the bearing. So another problem will solve where life of the bearing is given and with 90% of reliability. That is the second problem. And with the load rating of 4000 radial load and 3000 newtons as the action loading conditions, with the shaft rotation of 1400 RPM, the bearing is to be operated for 12,000 hours. So we require to operate the bearing for 12,000 hours. So which type of bearing it is suitable? So here I have solved the problem in two selection processes, that is 6219 series and 6319 series. So for same size of the shaft size of the bearing. If the shaft diameter is given, then the selection will becomes will be still simpler. Since 62 or 60 series, in which the diameter, based on the diameter of the shaft, you can easily select. But here in this particular case, the diameter of the shaft is not given. So therefore, you are free to select the type of bearing. But when you are considering, you can take two close values of 62 series, or you can select SKF 6219 series and 6219 series. So two different series I have considered for explanation purpose. So why it is 62 series is not suitable, and why is 63, which will be suitable? 6219 series is suitable or 6219 series will be suitable? So that we will discuss now. So here the given, as per the given data, the radial load is FR is equal to 4000 newtons and the axial load is 3000 newtons. The speed of the shaft is 1400 rpm and life is going to be 12,000 hours, that is at 90% reliability. So here according to the problem, so we need to calculate the equivalent bearing load, that is a combination of radial and axial loads, for which we need to calculate x, v and y values. So when you consider x, v and y values, again as I explained in the earlier problem, so we need to calculate FA by FR and FA by FR by C naught values. So here they note that the minimum value is given as 1 and therefore 0.56 x is considered. So here we are going by solving by iteration process. So here the selection of ball bearing is not done. So whether the selected ball bearing is correct or not. So for initial iteration, so we consider x is equal to 0.59 and y is equal to 1. So after calculating the equivalent radial load, so we'll get we'll get the values of it is observed that the x is a constant and equal to 5.7 and varying the value. Okay. So on the design, as explained earlier, the design equivalent load, if the service factor is given 1.2, you can multiply with the service factor, and the initial value of 7,860 newtons is calculated as the equivalent load. Since the life of the bearing is already given, that is 12,000 hours, so we need to convert it into millions of revolutions. So it becomes 1,008 millions of revolutions or rotations. So if we substitute in dynamic load capacity, so we will get 78,809. So this is the static loading condition as per the initial iteration process. So based on this loading condition, we need to calculate, we need to select a bearing in either 62 series or 63 series. So if you see 62 series and 63 series, 62 series 78,000 and odd, so we will lie at this is 6219 series of dynamic 82,870 is there. So therefore higher value is considered. The selection of bearing will become 6219 series. So here the shaft diameter is 95 mm. So therefore a similar series of 63 also you can consider. 6019 you can consider, where the dynamic load capacity is 1,17,690 is there. So therefore the selection of bearing I have considered. So in the examination point of view, you can select one bearing and you can proceed for iterations. Here for explanation purpose I have given two series. So here once the dynamic load capacity and static load capacity is noted down from the data handbook, So knowing that FA by FR and FA by C naught values we have to calculate. So earlier for calculation purpose the C naught value is not available. So therefore for initial iteration process, so this particular values of initial iteration process x equal to 0.56 and y equal to 1 is considered. So now this y value has to be refined. So corrected value has to be given. So for that purpose, so when you calculate the existing selected bearing for which the values is going to be FA by FR is equal to 0.75 and FA by C naught will be equal to 0.04219. So once FA by C naught value if you calculate, the value of E is 0.24129, so approximated as 0.24, and the corresponding FA by FR is greater than E, therefore so the Y value is again interpolated, so you will get a 1.841 is the latest one. So here I will explain after completing 6219 series, and then I will go to the 6319 series. So once we get the value of Y, X is constant 0.56 and Y is going to be 1.841. So therefore the load carrying capacity, equivalent load capacity is 7,682. So multiplying with the service factor, you will get 9,218 newtons. Calculating the dynamic load capacity from the equation, so you will get 92,429. So this is the first iterated value of the selected ball bearing. So whether it is suitable or not, that we will discuss after completion of the selection of bearing 6319 series. So here, before going to that, let me finish. The expected dynamic load capacity of 6219 series is 92,490 newtons, and the actual dynamic capacity is 82,890. So here the difference is very large. So therefore the dynamic capacity, actual dynamic capacity, and the expected capacity is going to be 92,000. So the selected bearing is having lesser value. So therefore the selected ball bearing will not fit. So what is the next iteration means you have to select the bearing with the higher load capacity. So therefore this is the second iteration of SKF 6319 series with a similar procedure. If you follow, the value of X is 0.56 and value of Y is going to be 1.52. So after calculating the dynamic load capacity is 6,800 and multiplying with service factor 8,160 and calculating the load capacity from the equation, that is C equal to P into L, that is you will get it will come together 81,817. So when you compare, this is going to be the dynamic capacity, which is has to be compared with the existing catalog. So that is catalog will be consisting of 6319 series. The actual dynamic capacity is 1,17,680, but expected after calculation you get 81,000. So therefore, so it can bear the higher load capacities. So and there is a thumb rule. The P value is going to be within the range of 0.3% of the total capacity is normally considered. So higher value is considered or recommended because of noise and vibrations in the ball bearing. So therefore, so excess expected value has to be considered for the selection of bearing of 60 series. So therefore, the selected recommended ball bearing is SKF 6019 ball bearing is selected in this particular problem. So here the main issues is selection of ball bearing. So the initial stage, how to start, that is initially we will consider X equal to 0.56 and Y equal to 1, and again we will calculate the dynamic load capacity. Based on that dynamic load capacity, so we will select a particular bearing and we will check it out after defining the value of X and Y values. Again we will check whether the values will be within the limit, that is expected value should be less than the manufacturer's catalytic value. So therefore the selection of ball bearing will be suitable for any operation. Some factors will not be considered, so therefore, in order to consider the other factors, so 3% of dynamic load capacity must be equal to the equivalent load. That means you have to take the bearing capacity more than the value of expected values. So therefore, the selection of bearing is very, very important in this particular record. That is a 3% to some textbooks they have given 2 to 3%. So therefore, you can choose the higher load carrying capacity of more than the value has to be considered than the expected value. So here I have explained two particular problems, and the assignment number 3 I already have given for you. So it consisting of two bearings at a time. So you need to calculate the same diameter of the shaft for a different operation loading conditions. So this is quite challenging, and the life of the bearing is given. The selection of ball bearing you have to do in a proper way. So I am giving an assignment for you, and please post your solutions by solving with similar procedural steps. If you have any doubts, please rise. I will try to clarify. So procedure is same. Procedure is same. 8 steps. That is you have to understand the two things. One is when the selected bearing is already selected, and you are supposed to calculate life of the bearing is one criteria. If the life of the bearing is given, then you need to select the ball bearing. When you want to select the ball bearing, the procedure I have explained in the problem number 2. If already the bearing is given, then how to estimate the life of the bearing, so that problem number 1 I have explained. If you understand these two problems, that is more than enough for selection of any type of ball bearing. So do follow the procedures for solving the problem. So if you have any doubts, please try to post the comments and other things. I will try to explain further going through the next topic. Thank you.